vectors question, we are going to look at the parallelogram. So in the figure below, not drawn to scale, ABC is a parallelogram such that DC is 3x, DA is 3y, the point P on DB such that DP, PB is ratio is 1 to 2. All right, so the information above here just tells you what's happening in this parallelogram below here. All right, so the first thing we'll do is label the diagram. Label the diagram. If AD, or let's use DA, direction of the arrow, if DA is 3y, CB is 3y as well. So here is 3y. If DC is 3x, therefore AB, look at the direction of the arrow, is 3x as well. All right. The study point P is on DB. So the point P is on this line, DB, such that the ratio DP to PB is 1 to 2. So that simply means D to P is 1/3 of the entire line, DB, all right? And PB is 2/3 of the entire line, DB, right? Let me just put DB one time. So just to elaborate, if you have a ratio 1 to 2, all right? So if you have a ratio 1 to 2, the total is 1 plus 2, which is 3. So this is DP, and this is PB, all right? So DP, right, for DP, we deal with the 1. So that is 1 out of the total, which is 3, and the total of what? The entire line, and this entire line is DB. So it's 1/3 DB, right? That is what DP is equal to. And similarly, PB, right? PB is equal to, well, PB, under the PB is you see in 2. So it's 2 out of the total, which is 3, multiplied by the length of the entire line, all right, DB. So this is just to help you understand where I got this from, all right? Let's continue. Okay, so we're going to look at part E. So part E tells us, express in terms of X and Y, AB, BD, and DP, all right? Now, when they say express in terms of X and Y, it simply means your answer will include X and Y, right? Your answer will have X and Y in it. So part E, we have part 1, AB, right? And we have to use the diagram, right? That's why we labeled our diagram first. AB, we have it one time. AB is equal to 3x. That's the answer one time. AB, 3x. This is part 1. Part 2, D, BD. All right, so we have BD. All right, so BD, we want to go from B and we want to reach D. So BD, I will say, is equal to B to C plus C to D. So that is BC plus CD. All right, BC plus CD. Pay attention to the direction of the line of the arrow, right? So opposite direction of the arrow. So BC is -3y, and CD is -3x. So we could put the negative one time, right? Usually I say plus minus 3x, right? But I put in the negative one time. So just to go over, BC is -3y, right? -3y, opposite direction of the arrow. And CD is -3x. So the answer for BD is -3y minus 3x, right? Now we come to part 3. We need to find out what is DP. we need to find what is dp. Now, dp is equal to, from the diagram, 1/3 db. So dp is 1/3 db, right? 1/3 dB. Right now, do we have dB? I will say yes. All right. If we look at this here, we see we have BD, right? We have BD. You have to look to see if you have the reverse of it. The reverse of BD is DB. So if BD is negative 3y minus 3x, then the opposite, which is dB, is positive 3y plus 3x, changes sign. All right, so we have 1/3, and we put 3y plus 3x. All right, remember, BD is negative 3y minus 3x. That's BD. DB, which is the opposite in direction, right? It's going this way. We have to change the signs, all right? So that is plus 3y plus 3x. Now to expand this bracket here, 1/3 times 3y is y, plus 1/3 times 3 is x. So basically, dp is y plus x. dp is y plus x, right? So this is part A. Let's move on to part B. Part B tells us, show that AP is x minus 2y, right? So remember, we need a diagram in order to figure out what things are. So AP. So AP, so we could either go this way or we can go this way, right? Keep it simple, right? Don't choose a long path, this long way, like you start from here and you're going around, right, to reach here. Don't go through all that. Start from here, shortest path, right? That is the wisest thing to do. So we have AP is equal to AD plus DP. So A to D plus D to P. And AD, let's see if we found it already. AD, so AD is equal to negative 3y because opposite in direction. So negative 3y plus DP, right? DP. Now, since we have DP right here, we found that already. We don't have to go and find it over. So we just include our answer, we substituted. So DP is y plus x. So here, we are simply put in y plus x. And when we transpose, see now the question has x first and y second. If I say x minus 3y plus y, I'll get x minus 2y, and that is equal to AP, right? So I show that AP is equal to x minus 2y. See, now they have it in this format. That is how your answer is supposed to look, all right? Next, we deal with this here. They said, given E, right? Given E is the midpoint of DC, right? Prove that APE are collinear. So firstly, let's deal with the diagram. They said E is the midpoint of DC. So let's assume the midpoint is around here, right? Let me zoom it. They said E is the midpoint of DC. And midpoint means if the entire line, well, in this case, the entire length of DC is 3x, half of that would be 3 over 2x. So across here, we would have 3 over 2x. And across here, we would have 3 over 2x, right? 3 over 2x plus 3 over 2x, you will get 3x. Check it out. All right. So we have our diagram here. They want us to show that APE are collinear. So let me just tell you about that. Let me start right here. We have APE. They want us to show APE are collinear. That's why I tell students. Write it down. They want us to find out APE, show that APE are collinear. So therefore, find out what AP is, and then find out what PE is, and show that one is a multiple of the other, right? So it's like if they ask you what is, show that ABC are collinear, we have to find out what AB is. Then we have to find out what BC is, and then show that one is a multiple of the other, all right? So let's jump into this right here. So we need to find out what AP is. Let's find out what AP is. And we don't really need to find out what AP is. Look, AP right here, they gave us this, which is good. So we know AP, right, a little better than that. AP is equal to x minus 2y. That's AP, all right? Now we need to find out what is PE. PE. So we need to find out what is PE. So where's P? PE. So we want to go from here to here, right? You wouldn't want to do this. All right, keep it simple. All right, PD plus DE. All right, so to move from here to here, PE is equal to PD plus DE. All right, so let me include that. PE is equal to P to D plus D to E. All right, plus D to E. Let's see if we have it. PD, do we have PD? Now, always look at your answers to see if the reverse is there. PD, we have DP. Since we have DP, we know what is PD. Just change your signs. So if DP is y plus x, PD is negative y minus x. So we have negative y minus x plus DE, right? DE is simply 3 over 2x, right? That came from the midpoint situation, 3 over 2x. So we have 3 over 2x. Right now, seeing that AP, we have x first and y second, we'll transpose and have x first and y second, right? So continuing, AP is equal to x minus 2y. And if I compare, right, I have a half here and I have x. So if I divide x by 2, I'll get a half x. So, which is the same thing here. If I have negative 1y here, if I divide this term by 2, I'll get negative 1y, which is the same thing here. So it simply means a half AP, right, is equal to a half x, because a half times x is a half x, and minus a half times 2y is simply y. So this here is the same thing as this on top here. So which is equal to PE, right? Since this is equal to that, and a half x minus y is equal to PE, we have to write PE here as well. So we can say, therefore, a half AP is equal to PE. And we can conclude that AP and E right, are collinear. So far we have part E, part B, and part C. All right, so we're going to deal with part D now. So part D tells us, given X is 2, 0 and Y is 1, 1, prove that triangle AED is isosceles. All right, so let's go on to this page here. I labeled the diagram already. All right, and we are going to focus on part D. All right, so we want to prove that a triangle AED is isosceles. So if I have, let's say this point is A, we have this point is E, and this point here is D, not drawn to scale. Right. So we want to prove that this is an isosceles triangle. Now remember the properties of an isosceles triangle. Two sides must be equal. Two sides must be equal, right? So once we get the length of two sides that are equal, the triangle is isosceles. So we need to find out the length of AE. When we're done with that, we find out the length of DE. When we finish with that, we find out the length of AD. Now, if you find the length of AE or you find the length of EA, you will get the same answer. Similarly for the rest, DE and ED is supposed to get the same answer. AD and DA is supposed to get the same answer. All right. So AE is equal to AD plus DE. And AD is equal to negative 3y plus DE is equal to 3 over 2x. So this is AE. All right, this is AE. Now, remember, x is equal to 2, 0, and y is equal to 1, 1. So x is equal to 2, 0, y is equal to 1, 1. Negative 3, we have 1, 1. All right, so plus 0, plus 2, 0, because that is what x is equal to. 2, 0, x is 2, 0. All right, we do the substitution, we get negative 3, because 3 times, negative 3 times 1 is negative 3, negative 3 times 1 is negative 3. And this one here, we have 3, 0. So AE is simply equal to negative 3 plus 3, negative 3 plus 0, 0, negative 3. That is AE. Right, now remember we have to find the length of AE now. So the length of AE is equal to the square root of 0 squared plus negative 3 squared, square root of 0 plus 9, the square root of 9, right? So AE is equal to 3 units. All right, so AE here, we can put 3 units. This question is very long, right? 3 units. Now we need to find out what AD is. So AD is equal to, put right here, AD is equal to negative 3y, opposite in direction. So I can write that right here. AD is equal to negative 3y. And remember, y is equal to 1, 1. So it's -3 by 1, 1, which is equal to -3, -3. That is AD. All right, so the length of AD, because we need to find what is the length of AD. So the length of AD is equal to the square root of -3 squared plus -3 squared, which is 9 plus 9, the square root of 9 plus 9, root 18 units. So we know AD is root 18 units. All right. Now, if AD was 3 units, we could have concluded, hey, it's an isosceles triangle. But we still would have had to find DE to make sure that is an isosceles triangle and not an equilateral triangle, because an equilateral triangle has 3 equal sides. All right. So the last thing we have to do, we know what is AE, we know what is AD, we have to find out what is DE. We have to find out what is DE. So we know DE is equal to 3 over 2x. So let me put it right here. DE is equal to 3 over 2x. You get that straight from the diagram, 3 over 2x. And x is equal to 2, 0. So this is equal to 3 over 2 by 2, 0. So when you multiply 3 over 2 by 2, we get 3, and 3 over 2 by 0, we get 0. So this is DE right here. Now the length of DE is equal to the square root of 3 squared plus 0 squared. 9 plus 0, well, 9 plus 0, which is the square root of 9, overdoing it with the work in here, which is 3 units. So we see here is 3 units. Here is 3 units. So they said, given that x is 2, 0, y is 1, 1, prove that AED is isosceles, right? So since AE and DE is equal to 3 units, all right. So I'm going to put it here. Since AE and DE, so AE is equal to DE, which is equal to 3 units. Is isosceles. So therefore AED is isosceles. This question is very long, very, very long. All right. So this is part A, part B, part C, and this here is part D. All right. So that's it for vectors, in this case, parallelogram.